At the dawn of time, before galaxies swirled, before stars ignited, before space itself stretched into existence, there was nothing. Or rather, something so strange and incomprehensible that our very laws of physics struggle to describe it. This enigmatic state is what cosmologists call the initial singularity, the theoretical point at which the entire universe was compressed into an infinitely dense, unimaginably small, and mind-bendingly hot point. What does that mean? How did it lead to everything we see around us today? Could something have existed before the singularity? To answer these questions, we must dive into the realms of physics, time, and the deepest mysteries of existence itself. The initial singularity is the hypothetical state that existed before the Big Bang, the moment our universe began expanding. Imagine every galaxy, every atom, and every particle of energy crammed into a single, infinitesimally small point. This point was so dense and so hot that the normal laws of physics as we understand them ceased to function. In mathematical terms, a singularity is a point where quantities like density, temperature, and spacetime curvature become infinite. That means infinite density. All the matter and energy of the universe was compressed into a single, zero-volume point. Infinite temperature. Heat beyond anything we can fathom, surpassing even the interior of stars or black holes. Infinite spacetime curvature. Space and time as we know them did not exist in a conventional sense. It is important to note that this is not just science fiction or wild speculation. The concept of the initial singularity emerges naturally from Einstein's general theory of relativity, which describes how gravity affects the fabric of spacetime. When we mathematically rewind the expansion of the universe, we arrive at this singular point where our equations break down. But if physics breaks down at the singularity, how can we even study it? To understand the initial singularity, we must look at two of the greatest scientific theories of all time. 1. General Relativity, Einstein's theory of gravity. General relativity describes how gravity works on a large scale, governing stars, galaxies, and the universe as a whole. When applied to the universe's expansion, it suggests that if we travel backward in time, everything shrinks down to an infinitely small point, the singularity. 2. Quantum mechanics, the physics of the very small. Quantum mechanics explains how particles behave on the tiniest scales, within atoms and subatomic structures. General relativity does not work well at these scales, so we need quantum gravity to understand what truly happened at the singularity. The problem? We don't yet have a complete theory of quantum gravity. This means that while general relativity predicts the initial singularity, quantum mechanics hints that something deeper and more complex might be at play. Could there have been something before the singularity? Did the universe emerge from something else, or did time itself begin at that moment? One of the biggest mysteries in cosmology is whether the initial singularity was truly the beginning of everything or just a transition from a previous state. Here are some intriguing possibilities. 1. The cyclic universe, endless cosmic rebirths. Some scientists propose that the universe goes through endless cycles of expansion and contraction. According to this theory, the Big Crunch, a collapse of the universe, could have led to the Big Bang, creating an eternal cycle. This idea is inspired by ancient myths of cosmic rebirth and is being explored through modern physics. 2. The multiverse hypothesis, a universe among many. What if our universe was born from another universe? Some theories suggest that our Big Bang was just a local event in a much larger multiverse, where new universes constantly form. Quantum fluctuations or collisions between parallel universes might have triggered our cosmic beginning. 3. The no-boundary proposal, Stephen Hawking's theory. Hawking and James Hartle proposed that the universe never had a beginning, in the way we think. Instead, time could have behaved like a sphere, where there was no first point, just a smooth transition into existence. In this model, the initial singularity is replaced by a quantum state with no sharp boundary. 4. The cosmic bounds, the universe that never began. Some quantum gravity models suggest that the universe was never infinitely small. Instead, a previous universe contracted to an incredibly small size before bouncing back into expansion, skipping the singularity entirely. This avoids the need for infinite density and provides a way for physics to remain consistent. While these theories remain speculative, they highlight a fundamental truth. The initial singularity is not the absolute beginning, but rather a moment beyond which our current physics cannot yet see. Understanding the initial singularity isn't just about looking into the past, it's about unlocking the deepest secrets of the universe. 1. The nature of time itself. Did time begin at the singularity, or did it exist before? If time had a beginning, What does that mean for the nature of reality? 2. The search for a theory of everything. A complete understanding of the singularity requires merging quantum mechanics with general relativity into a unified theory of quantum gravity. Such a theory could reveal the fundamental rules governing all of existence. 3. The possibility of other universes. If the singularity was not the absolute beginning, then other universes or previous states of existence may have left imprints on our own universe. Cosmic background radiation and gravitational waves could hold clues to what happened before the Big Bang. 4. The future of the universe. If singularities exist at the beginning of time, could they also exist at the end? Studying singularities in black holes could help us understand whether our universe will expand forever, collapse, or transition into something new. The initial singularity remains one of the greatest scientific mysteries of all time. It represents the limits of human knowledge, the point where all our theories collapse, and where the deepest questions of existence remain unanswered. Was it truly the beginning of time, or just a doorway from a previous existence? Was it a singularity at all, or do we need new physics to describe what really happened? As we develop more powerful telescopes, refine our mathematical models, and push the boundaries of physics, we move closer to unlocking the mystery of our cosmic origins. Until then, the initial singularity stands as a reminder that some mysteries are so profound, they redefine our understanding of reality itself.